Hello everyone, welcome in this new episode of Daily Coding where we are going to go through remove duplicate letter. So this problem is actually a scenario where you have as input a string and you're supposed to remove duplicate letters. At this point it sounds like an easy problem, but the tricky part is that you should remove it in such a way that the result string you are returning is the smallest in lexicographical order. That means the smallest possible. Let me give you an example so you understand better. So let's say I have an input BCABC. One possible solution with no duplicate is BCA. When you have, if you have BCA, there's no duplicate in BCA. But the issue with BCA is that it is not the smallest in lexicographical order. Why? Because we do have another output ABC, which is actually smaller than BCA. Now, given that, how are you going to organize yourself to achieve the result? So my idea will be as follow. So me to have that result, what I will do is that I will keep track of the frequency. That means I will count the number of occurrences of each of the character in my string, and then I will have another map that will be used to see if an array, if a character has been taken or not. Why am I saying that? Because I have a logic that I'm going to implement. I'm going to share that with you, and I have a result string here. So those are my initial variables. And then to fill my array of frequency, I need to look through the characters, and then whenever I'm seeing a character, I increment the frequency there. So that's what I've been saying here. So I'm going to iterate through each character and calculate the character frequency and populate the frequency to the map accordingly. So that's what I'm doing here. Now, I'm diving into the for loop where I have the core logic of my algorithm. Before diving into the core logic, let me explain something to you. If you have an input like this, right, your approach of solving this will be as follow. Whenever you see a character which is not present, you should take it. But before taking it, you should make sure that there are no character before that character that is going to break the lexicographical order. Whereas when you see a character which is already present, you just keep it. First, are you present? No. Is there any character before you that is going to break the lexicographical order? No, because I'm the first character. So I'm going to take this. C, are you present? No. Is there any character before you which is going to break the lexicographical order? No. So I'm taking this. What do I even mean by is going to break the lexicographical order? A character is going to break the lexicographical order if there is a character before him which is greater than him and that character also appearing after him. It will break the lexicographical order in the sense of it will be better to take the one after. So that is the idea. We are going to see it while moving. A, can we take A? No, A is already present, so we don't take it. B, can we take B? Yes, B is not present, we should take it. But before taking B, do we have any character before B which is actually which is going to break our lexicographical order? Yes, we do have. Why? At this point, our result is AC. So at this point, our result is consists of A and C, right? It consists of A and C. Now you are going to take C, you are going to check, like I just said, a character is breaking the lexicographical order if it is present before you, it is bigger than you, and it also appear after you. So we are going to say, okay, does C is greater than B? Yes, it is the case. Is C actually appearing after B? Yes, it is appearing. So we are going to erase this. So we are going to remove all the characters that are possibly going to break the lexicographical order, and we are going to add this at the end. So at the end we are going to have B. And then now we are moving here. So we took this. Now C, is C present? C is not more present because we remove it here. So that you now understand why we need a tracker that is going to tell us which character has been taken or not. C is not present, so we take C. So we have C. So the result will be A, B, C. That is why here I'm going to have my error frequency being decreasing whenever I'm taking a new character. I'm going to make use of it to check if a character exists after, because here how was I able to know that there is a C after B? Because the number of character of C at that position was actually different from 0. So what you're going to say is that if a character is already taken, you continue like we just said. Now if the character is not taken, you should make sure that before taking it, you remove all the possible characters that are going to break the lexicographical order. That means you are going to check if you have an element which is actually greater than me. Me is the guy I want to add. If there is a character which is greater than me, and that character which is greater than me is actually appearing after me, because if you still exist in the frequency, that means you also appear after me. So if those two conditions are respected, we are going to say, oh, you are not taken anymore, we are going to take you after, and then we are going to remove you from our result. And by removing all the characters that are possibly going to break the lexicographical order, we can now add our desired character and consider that character as a character that has been added. And at the end, we are going to have our solution. So let us run and see what it gives before we end it. So we can see that our solution is actually working. We have everything green and it is even performing great. We have a good, in fact, we have a good percentage. So this is my push-up solving. I hope you do enjoy it. Feel free to leave me any message, any comment that you think can help to improve or to make anything better here. I'll be really happy to interact with you. See you on the next video. Ciao.